Now let us discuss the motion of the particle being attracted towards the center of the earth. Now the earth attracts, you have to note down this thing that the earth attracts a body outside its surface with a force varying inversely as a square of the distance. That means if the particle is above the surface of the earth whose distance is x from the center, then in that case the force here will varies inversely as a square of its distance. So if x is the distance, then in that case force will be proportional to 1 by x square. And when a body is inside its surface, that means when a particle is inside the surface of this sphere or the earth, then in this case it will be directly proportional to the distance x. That means md2x dt2, which is the equation of the force, this will be equal to will varies as x, where x is the distance of the particle inside the surface of the earth from the center O. So now here we have to use this two condition that when the particle lies outside the surface of the earth, then the force will varies inversely as a square of the distance, and when it is inside, then it will varies or directly proportional to x. Now let us take r to be the radius of the earth. So as we consider the earth to be a sphere, so let us take the radius of the earth to be r, and let O be the center of the earth. Now take P to be the position of the particle at any time t above the surface of the earth. And let us take A to be the position of the particle which lies on the surface of the earth. So on the surface of the earth, we denote the position of the particle at A which lies on the surface. Now let us take OP to be x. That means the distance from here to here is equal to x. Then the equation of motion will be given by d2x dt2 is equal to minus mu by x square. Since it is attracted towards the center, so it will be minus sign. Now here you please note down this one. Since the body lies outside the surface of the earth, then the force will varies inversely as a square of the distance. What is the distance from P to O? It is x. So that's why we have the acceleration here as d2x dt2 is equal to minus mu by x square for x greater or equal to r, the radius of the earth. And if it is inside, if the particle now comes inside the earth, then in that case equation of motion will be minus, this one should be lambda x for x less than r. That means if the particle is somewhere here inside the surface of the, inside the earth. Now at A, that is at A which is on the surface of the earth, the distance from here to here, that means x will be exactly equal to r, which is the radius of the earth. Therefore, in this case, the acceleration, that is d2x dt2, will be equal to g, where g is the acceleration due to gravity on the surface of the earth. So we'll get the first one, mu by x square is also equal to g, and lambda x, you replace x by r, which is on the surface, also will be equal to g. So we'll get here mu by x square, r square is equal to g, and from here you can calculate the value of mu. So we'll cross multiply this one to this side, you get mu is equal to g r square. Let us denote it by star for x greater or equal to r, and inside the surface of the earth which is less than r, then lambda r is equal to g. That means lambda is equal to g by r for x less than r, and we denote it by double star because g here is the acceleration due to gravity on the surface of the earth. Now let the particle be attracted towards the center of the earth starting from rest at infinity. Now suppose this particle start from rest whose distance is infinity from the center of the earth. That means x will be infinity and the velocity will be equal to 0 at that initial position. So then from equation 1 we'll have what? From equation since P lies outside the surface of the earth, so in that case we have to use this equation 1, that is d2x dt2 will be equal to minus mu by x square, or v dv dx is equal to minus mu by x square. But from equation star we see that mu is equal to gr square, so we can replace it by minus gr square by x square. Simplify, cross multiply this one or separate the x and v variable, then you'll get v dv is minus gr square by x square dx, and integrate this one, you'll get v square by 2 is equal to gr square by x, because the integral of minus 1 by x square dx will be, the integral of 1 by x square dx will be minus 1 by x. So minus and minus will be cancelled. Then you'll get it as this one. So cross multiply these two, then you'll get v square is equal to twice gr square by 2 or gr square by x plus c, where we substitute twice c1 by c because 2 and c1 are constant, so we can replace it by another constant c. Now, initially, since the particles start from rest, whose distance is infinity from the center of the earth, so when initially v will be equal to 0 when x is infinity. So you substitute this value of v is equal to 0 and x is equal to infinity in this equation 3, this one. Then 0 here, you'll get 0 square is equal to twice gr square by infinity plus c. But something divided by infinity will become 0. So here the value of c also gives you 0 because this side also it is 0, this value also is 0. So you'll get the value of c as 0. Now finally we'll get the velocity v square as twice gr square by x. So on reaching the surface, this is the velocity at any time t whose distance is x from the center of the earth. But on reaching the earth's surface, that is on the surface of the earth, that is at point A, whose distance from O will be r, same as the radius of the earth, then in that case you replace x by r. So on replacing x by r, you'll get v square is twice gr square by r, or v square is twice gr. Take v is equal to square root of twice gr. Here I'm taking, because we don't need to calculate that distance and x. So we just take the positive square root here because we consider velocity as the absolute value of the velocity. So now suppose the particle goes inside the earth surface through a hole. Now suppose on reaching the surface of the earth, the particle penetrates inside the surface of the earth. Then in this case, the equation of motion is given by equation 2, that is d2x dt2 is equal to minus lambda x for x less than r. But what is lambda from equation double star? You can see from here it is g by r. Replace the value of lambda by that one. Then you'll get minus g by r into x, or v dv is minus g by r x dx. Integrate this one, you'll get v square by 2 is equal to minus g by r x square by 2 plus c2. Or v square is minus g x square by r plus twice c3. So now you put twice c3 is equal to c4. So it becomes minus gx square by r plus c4 as equation 6. But we know that v is equal to square root of twice gr from equation 5, that is when x is equal to r, that is on the surface of the earth. So now you replace the value of v now, because initially from the surface of the on the surface of the earth the velocity is this one. So you have to use that the initial condition, the value of the velocity on the surface of the earth. So replace it by square twice gr whole square. And then x also has to be replaced by r. So it is minus gr square by r plus c4 to evaluate the value of c4. On simplifying this one, you will see that the value of c4 is 3gr. Substitute this c4 in this equation. Then you'll get v square is minus gx square by r plus 3gr. Now, on reaching the center of the earth, what will be the velocity? Let us see. When x is equal to 0, that is at O, which is this center. So on reaching the center of the earth, so that is x will become 0 because x is the distance of the particle from the center. But now on reaching O, x will become 0. So substitute x is equal to 0 now in this equation 7. Then you'll get v square is equal to minus g into 0 square by r plus 3gr. Then this will become 0. So you'll get v square is 3gr, or v is equal to square root of 3gr. That means the particle will reach the center of the earth with velocity v is equal to square root of 3gr. But to reach the surface of the earth from when the initial position of the particle is above the surface of the earth, then it will be square root of twice gr. Now hope it is clear with this explanation regarding the motion of the particle when it is attracted towards the center of the earth.